That's chem.
Uh-huh.
Yeah.
I'm sorry, what happened? Sorry, what happened?
Chem is in week 6, but this
Ah,
week I have literature and English.
right. Oh, your school style is a little bit by a little bit by a little bit lah.
Yeah.
Um, us personally, do you like that or not?
No, I don't.
Oh, you prefer a fully packed week, ah?
Yeah, because right now it's so spread out and we still have a lot of homework. So it's like we have to study and do homework.
Oh, wow. Okay. Interesting. Okay. I write down, okay. Your personal preference become even more important. Oh, really? You don't mind a packed exam? Wow. Wow.
I feel like it's better if it's all in 1 week than like they remove the homework for that 1 week. So you
I mean,
can focus.
true. But it's because you have good notes and you can revise quickly, isn't it?
Yeah.
Mm-hmm. Makes sense. And you're not scared of pressure.
Oh yeah.
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 Mostly.
Hopefully that's still true this year. Of course. So what do you call next week? Is next week week 3 or week 4?
Next week is week 4.
So tomorrow, Monday, is week 4.
That's right.
Okay. So that means you have 2 weeks lah, not 3 weeks lah, right?
Yeah.
Okay, so sad. Okay, now week 4. Tomorrow's week 4, and then what happens? Wait, why is school tiring? Why has school been tiring for you, if I may know?
There's it's a bit hard to adjust back to like the workload.
Oh, okay, right.
I think it's a lot higher this year actually.
Should be. You're saying that the teachers start very strong this year, just boom.
Yeah.
How do they exactly boom you guys?
Class is okay. It's not hard to keep up in class, but they give a lot of homework. So it's hard to keep up with that.
Okay, but a lot of homework. Okay. Tell me more. If not, go into the details of chemistry. I will ask also. Tell me more.
Chemistry.
So what has been happening these 2 weeks, Alice?
We did a lab lesson. So
Huh?
we did an experiment from the reactivity activity.
Wait, in these 2 weeks, you have been doing practical lessons.
Oh no, we only had like 1 lesson.
And why is that so?
Because the previous lesson the teacher was absent. So they just sent in a relief teacher and
My head. Never mind.
Okay, wait, could I get my chemistry file? It's outside.
Yes, please.
Okay, thank you. Oh, yeah, we did have 1 class lesson. I forgot about that.
When is that? What is it about?
We just went through the homework, the holiday homework.
Which is on?
Reactivity.
Oh, you never asked about your holiday homework, isn't it? Oh, wow.
Holiday homework?
Yeah.
Oh no, because I lost it.
And then you found it again.
No, the thing is, I already did it like early in November and then I lost it. So I have to redo it.
Oh, but you can do it. You can?
It's okay because it was just following an SLS lesson.
Right. That's fine. Okay. No problem. So you check your home, which is basically just revising the basics of reactivity series.
Yeah.
So how come chapter 15, right, is declared done? I don't get that. Is it done or not?
I don't think we are done because she gave us more homework on chapter 15.
Okay, makes sense. The activity series is a big one, is an important one, right? Okay. So we are at chapter 15. Okay, good.
I think next we're doing gravimetry.
So repeat that, sorry.
I think we're doing gravimetry next.
Why are we? What? In the reactive, in chapter 15, there's a gravimetric next.
Gravimetry.
Gravimetry?
Yeah, I'm not sure what it is. Energy changes.
Why is it called? Oh, sorry. Could you no. Energy changes. It should be the next chapter. No.
I think so. She gave us a handout already.
So she's giving you more homework on reactivity series, but also the next chapter.
Yeah, but the homework, she didn't ask us to do it yet.
That's very weird. Does your teacher usually give you the handouts of next chapter before this chapter is done?
Yeah, I think so.
Okay, that's fine. Okay. Because I'm very confused if there is sign of the chapter finishing, right? Cannot be.
Yeah.
So I'll just say chapter. Yes, go ahead.
Based on the chemistry scheme of work, this week we're starting chemical energetics.
Energetics, energy changes, enthalpy, whatever, and endothermic, exothermic, that kind of thing.
Yeah.
We call that chapter 16.
Okay.
But does your teacher stick to the scheme of work?
Yeah.
I am very sad. So according to the scheme of work, chapter 15 is supposed to be done when?
It's supposed to be done by the first lesson of this coming week.
Okay, never mind. Okay. What? It's an adventure every day. Rachel, you're hearing this. This is for you also, right? Hope you are safe and sound and happy with the family. And do catch up with us today. Okay, mole oxidation. Oh, okay, good. Periodic table and reactivity series. Okay. Today we have no videos and everything. Okay, so a little bit difficult, but you have your chapter 15 notes with you. I need to confirm a few details. Okay. Does the chapter have, of course, what you call the reactivity series, the one that I teach you to then
Yes.
And does your teacher teach you another way of memorizing?
She didn't give us a way of memorizing.
That is very sad. Okay. Now the reactive series, is it longer than this? Basically, you have a C, you have a H, three, well, not three. This is group 1, group 2, group 3. So there's actually usually 2 here and 2 here. So 5, 3, 3, basically. Is it longer than
that? There's 2 above C. No, sorry, 4.
4. Okay, sure. Then in the middle?
In the middle, there is 3.
Good. And afterwards, only 3 also?
Yes.
Okay,
I think the 4 above is missing aluminum though.
Yeah, aluminum should be there, even though it is almost never used, but aluminum should be there. Good. Okay, good to know. Standard. Okay. Now, then after reactivity series, there are a few applications that is almost immediately application, because reactive series is never not an application. Never. It's never. So let's see. Do you talk about blast furnaces?
Not yet.
What do you mean by not yet?
I don't see it in the notes at all, actually.
Okay, good. So because technically it is removed from the syllabus, but you know, your school does its own thing, right? Okay. So blast furnace, let me repeat, you're talking about, I'm mixing coal with iron oxide to give iron, melting it and whatever not. None of that.
Nope.
Okay, good. Now, rust prevention.
Yes.
Does it feel significant? As in, it feels like a big part.
It was our homework for this weekend. I was doing it just now.
Okay. Then, does it talk about redox? You know, the redox from the previous chapters.
There's no link to that in here yet.
Very, very sad. Okay. Okay, trust me, you will. What else? The trends are reactivity trends, though. So reaction of metal with cold water with steam, with dilute acid, that kind of thing.
That was on the first page of the notes.
And they're presented as tables and they're presented as something to memorize.
Yeah, it's just metal plus cold water is metal hydroxide and hydrogen.
No. I mean the speed. Oh, no, the speed of the reaction itself.
No.
Oh, no. Right. So no mention of metal carbonates also.
Only in the... Oh, no, not at all.
Then the notes seem very thin. What else am I missing?
There's a... sorry, no. The table is here.
Okay. Again, it contains the reactivity series, right?
Yes.
Order.
And then reaction of metal with cold water, steam, and hydrochloric acid.
Good. Only these three? No,
there's carbon, hydrogen, and by heating.
And what, sorry?
Carbon, hydrogen. Oh, sorry. This one is reaction of metal oxide.
Yeah, no problem.
With carbon, hydrogen. Then the last one is thermal decomposition of metal carbonate.
There you go. All right. Yeah. So we do have that.
I did not memorize this.
You will need to, but I'll show you how to do it quickly, I suppose. Then what else?
The experiment
Meaning?
that we did in the lab, it was like the wells. Oh my gosh, I don't know how to describe this.
The wells.
So there's 3 pieces of magnesium metal, 3 pieces of iron nail, and 3 pieces of copper metal. And you're supposed to put them each into like a different substance.
Displacement reaction, isn't it?
I think so.
Like, does the metal disappear or not? Does the solution change color or not?
Oh no, does the metal have any reaction happening to it?
Yeah. So not disappear, but let's say the metal reacts and produces maybe something .
Yeah, mostly rust. Like I think all of it was rust.
Right. Non very dangerous, non very speedy, right? Just nice, easy stuff.
Yeah.
Okay. So those are displacement. Now, does your note specifically mention displacement reaction?
No.
Okay. What else? Okay. Anything else that I'm missing?
The displacement is like the homework also.
Okay. Again, what
but
else?
Like there's no notes on it. It's just questions.
What else?
Then after that was just rusting.
Now the rust prevention, help me a bit, they talk about painting as a rust prevention, right? Painting, coating with oil, that kind of thing. The one which is not chemicals.
Our notes are really useless.
You're making me depressed.
I'm sorry. Wait, it's just like blanks, then they make you fill it up.
And they don't help you fill it.
No, but for the rusting one, they gave you like a statement and then they ask you whether it's true or false, and then you're supposed to write out the correct statement, the corrected statement.
Okay, now the rust prevention part, is there something called sacrificial protection?
No.
No? Metal protecting other metals, no?
No.
There's a big ship made of iron, and then you patch magnesium metal on it to prevent the big metal iron floating ship from rusting. None of that?
It sounds very familiar, but it's not in the notes.
I am very, very stressed.
No, but it sounds familiar. Did you go through it before?
I guess so. And trust me, they like that a lot in exam. I don't think your exam will be different, right? Okay, what do they say in rust prevention? Give me some bullet points, maybe.
Okay, so the first statement is when iron rusts, the product is iron 2 oxide.
Not very helpful. Thank you very much. We know that then. Hi.
Wait, that's true?
Oh, that's not. Oh, you don't know that. You do not know that rust is iron oxide.
Is it? I don't know. I googled it.
Oh, then it is useful. Okay, I don't know what's going on, but okay, rust is oxidized metal.
Oh, but then the thing is, when I googled, they said that iron 2 oxide is wrong and it's supposed to be iron 3 hydroxide.
Let's simplify our life and just know for now that rust is oxidized iron. The point that they're trying to make is the metal is no longer metal. I suppose that's obvious from our day-to-day observation. The metal is no longer metal and therefore it's no longer reliable. Which is rust is something we want to prevent.
Yeah.
What they don't spell out clearly so that, look, rust prevention is not something only a chemistry student can understand. Everybody can understand we want to prevent rust, correct? Right?
Yes.
So when you're studying chemistry, you're studying something deeper or something that normal people don't understand now. But let's see whether you understand this one. Metals do not like to be metals.
Oh yeah, okay.
That is
stable.
Good. They are whatever, they are reactive, they are unstable. They want to be metal ions.
Oh, okay, yes.
As a chemistry student, you're supposed to think like that. That's basic, by the way. That's everywhere. So, and they can only do that when they find somebody willing to accept the electron. In this case, oxygen is abundant on Earth. In this case, lah.
Yeah.
And water is another way. So, but never mind water, slightly more complicated. So Fe2O3 is a very natural result of a metal stopping becoming a metal because a metal do not want to be a metal. And as a human being, we want metal. We do not want the metal ion, as in not in daily application, at least. Okay.
Wait, so metal ions, are they like unstable?
No. So this is what you need to understand as a chemistry student. This is very basic chemistry. If metal does not want to be metal, right? So therefore it is called unstable. Simple, right? They are unstable because they want to change. Then they change to metal ion. The simple logic is metal ion is stable.
Oh, okay. So basically metals are not stable.
Less stable, let's just say that, reactive. Okay. And metal ions are, well, therefore stable. Okay. Doesn't mean that metal ion cannot change, but it is definitely more stable. I mean, if you're unstable, why do you change to something even more unstable? That doesn't make sense. Right? If you're writing that, that's good. They, for some reason, never say it clearly, but it's a very important thinking. That one I can guarantee you, right? That's Rust prevention is the prevention of metal becoming metal ion. That is only something a chemistry student will understand. Okay? As a result, normal people will understand if I prevent rust, I can just paint or I can just give oil. Because the normal understanding is I want to stop iron from being in contact with water. Somehow water helps with the rusting process. But that's common sense people, not chemistry student. Okay? In a chemistry student, you learn that, oh, rusting is metal becoming metal ion. It's not just Fe metal, it's every metal. So to prevent that, I can do many other things. Now that's what you're studying. And most of those things are very complementary, making plus paint or plus coating effective. So more effective if you combine them. In some other cases, coating or painting is incompatible with the techniques, which are usually more effective. So just be careful.
Oh, okay, wait. Did you say that rusting is metal becoming a metal ion?
Look, common sense, yes. It's just that technically rust is reserved for the word for Fe only. Rust is the word reserved for Fe only. The more general word is called oxidation.
Oh, so oxidation?
Oxidizes. When a metal becomes a metal ion, the metal oxidizes. Why? Because the metal needs the help of oxygen. Needs the help. Which is, again, a chemistry student needs to understand this.
Okay.
Okay. Now, you cannot say rust for aluminium. You cannot say rust for magnesium, but everybody oxidizes. Everybody turns to metal ion. Just call that oxidizing, which is why I was asking, do they mention redox? Because it's there immediately. So far, so good?
Yes. Wait, I'm sorry to like jump topics.
No, jump. You need to jump. You don't have
Okay, you know the iron oxide? I'm really confused with acid bases, the bases.
right. Okay. So
Is that a base?
right. So I'll tell you the good news first. I think your wa1 will not dare touch acid-base reaction because they'll be too much. They'll kill a lot of people. But your question is valid. So I answer it because it is important, not because it is in exam. Fair, yeah? Iron oxides and ions or iron hydroxides, right? Metal oxide, metal hydroxide, all function as bases. Now you must understand the definition of base. The simplest way for you guys to understand it is base reacts with acid. Acid reacts with base. The reason why you want to think, oh, iron oxide is base, simply because when you see another acid, you know immediately they will react. That is the sole function of knowing iron oxide, iron hydroxide as bases. It will react with acid. Do you understand? Am I answering your question?
So all oxides are bases?
In the acid and base chapter, you learn that there are 4 types of oxide. Metal oxides are bases usually, except for they give you 3 metal oxide which are amphoteric. Remember that? Amphoteric means they can become base or acid depending on who they meet. They are but that's not all oxides. There are also non-metal oxides which you never think of as like carbon dioxide, oxide, right? H2O, oxide, but you never think of it as water. But they are all non-metal oxides. Non-metal oxides are acidic except for 3 neutral ones. Same thing, the exception. So don't say that not all oxides are base. All metal oxides are bases. Except for 3, which are very flexible. Go on.
Yes.
Don't think they will test that yet. Don't think. It's a very big thing in the end, but maybe hopefully not wa1.
Okay.
You say or I say?
Okay, I kind of got it.
So I still don't get your rust prevention chapter. How come we are not discussing anything worth rust prevention?
I don't know why the notes like have nothing helpful.
Very sad. Okay, I understand your notes. So we have basically covered your notes.
Yeah.
Okay, I will go through redox and reactivity series in a slightly different point of view. Okay. And then hopefully that helps. Now, reminding Vera, Rachel, and everybody else, the way we see science and math should be like this. Hey, I want to learn whatever stays the same when the question changes. Right? Whatever question they ask me on this topic, the question will change. There's an infinite variation of the questions because there is infinite variation of the reality. Very easy for them to make different question. They know more about the reality out there, right? So the question changes. You want to learn what does not change in the answer. Don't be like, in terms of science and math, please don't be a person who hope the question is the same as what you have practiced. It's a very natural hope, but that's not going to work. You want to learn what answers or what principles stay the same. Fair?
Yeah.
We cover that immediately. We don't wait. So I'm presenting to you what I think will never change and therefore will always be useful. Fair, yeah?
Okay.
I have to confirm the device situation first. So you're still using your same iPad. There is no changes at all in your good notes. You're still all good.
Yes.
Remind me again because good notes are good. Can you still share with me?
Share the notes?
Yeah, share some notes with me.
I can share a link to collaborate.
Yes, that's it. As in your good notes 6, is it? Is a full version.
I think so.
Because you buy it once? No.
I didn't buy it.
This is a free version.
Yeah.
How you can only share a little bit. Okay, sorry. Got it. And I did share some notes with you, and they are still there. There are no disruption. There are no changes. Whatever.
I don't see them.
Oh. Wait. My concern is not that because I can always reshare that, right? But my concern is that you probably have modified them for your own use, right? That's the reason why I share with you. All those are gone.
I think so.
Do you know why that happened?
Yes, because previously I think you shared it when I was using my mom's account.
Tell me what changes happened. Your mom's account and whatever.
I think you passed me this iPad, right? Then I logged into my own account on this iPad because I couldn't log into my mom's.
When did it happen? When you changed to your account? November, December, yeah, kind of thing.
Whenever it was that you passed me the iPad.
Hey, wait. No. But wait.
It was when you passed me this iPad.
No, probably that means I never share with you any notes, but you made it yourself when you're following the tuition, something like that.
Yes, I have.
Those things are there.
Yeah.
Oh no, doesn't matter. Whatever. Okay, so you're currently using your own Apple account, something like that. And this is your first iPad, kind of.
Yeah.
The good notes. I see what you mean. Okay, understand. No, this is good. This is good because the situation with people who is using iPad from school is very complicated right now. Right. Good. Any other changes or anything you want me to know?
My mole concept is kind of weak.
Which is bad.
No, because we had a lot of homework for the school holidays, and one entire part of it was moles. And like I did it, I thought it was like okay, but then when she shared the answers, I was marking it just now. I got quite a few wrong.
Mm. Mm, 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 mm. Let me think for a while. Give me 1 minute. Hmm. Hmm. Okay. Question. Let's say your notes are not very useful, right?
Mm-hmm.
My question is, are your homeworks and practices useful? Meaning they help you with the basics, which is important, right? That's number one. Two, they actually give you a very good sense of what the exam will be like. So number two, are your homeworks useful?
Are they useful? Not really.
Okay, tell me why they are not useful.
I don't feel like I'm learning anything.
Really sad. And when you see the answer key, you're still not learning anything.
Oh, the holiday homework?
I guess more like the chemistry homework in general.
In general. So like the holiday homework was pretty useful.
Okay, great.
Yeah, but the problem is I'm supposed to mark it and hand in by tomorrow latest because it's been dragging on for a while, but I haven't finished marking it because I haven't had the time.
Okay, all right. A problem that can be solved, but it's useful.
That one, yes. But my daily chemistry homework, like the one she gives after lessons, is like kind of not really useful.
So let me get this straight, yeah. Your notes are not useful for some reason.
Yeah, because the notes is the homework.
Right. Yeah, okay. That's right. So you cannot rely on the class for some sort of useful notes, right? You cannot.
Yeah.
You also cannot rely on the class for useful practices. Again, a practice that strengthens your basic number one and then give you an idea what the exam is like. These two functions.
I think that would be like not too bad. Like,
what do you mean? Huh?
like the notes are not very good, but there is a practice worksheet that she hasn't asked us to do yet. But I think it's not that bad. I think it could help.
Helps with
Help us practice for
basics and exam level.
yeah. But she hasn't asked us to do it yet, so I'm not sure.
So let's see. The more homework is the holiday work. The redox homework, periodic table homework, and reactivity series homework are not done yet.
Redox and what?
The three other chapters.
Redox, reactivity, and
Periodic table, I think.
periodic table. I think we did periodic table last year.
No more homeworks. How about redox and reactivity series homework?
Redox homework, I think it might have been last year too.
Okay. Periodic table. No. The reactivity series homework is now within your hands, but you have not done, and that's fine. Okay, good. Okay, Okay, you know this better than I. I was telling everybody in school, when school starts, whatever, the school tempo is not necessarily friendly. You will be more tired, obviously, compared to holiday. And even following the class is sometimes not very clear-cut useful, but you know that better, right? That's why we're intuition. Now, let me give you a very brief prediction what will happen for these few months. Now it's clearer to me, and then we'll start doing hopefully 2 useful things, right? So your chapter 16, I promise you, is not a hard chapter to understand, and it is going to be a chapter that should be quite easy to practice well. Okay.
Okay.
Energy changes, and then usually followed by speed of reaction. For some reason, people tend to be okay with these 2 chapters. Okay, so there is a brief, but these 2 topics are rather popular in exam because they're very practical topics. Easy doesn't mean they're not important. They're very practical, they're easy to make questions, and the exams like them. So now, if anything bad happened in these 2 chapters, meaning notes are not there, teacher absent, no practices, no useful stuff, well, that's not going to be easy. You still have to do something, right? Then the break doesn't happen, no, the good break doesn't happen. And then you're going to tell me immediately, because looks like your teacher is just going to teach through those chapters, not waiting for WA to finish. Correct?
I think so.
So you'll be learning something new and not preparing for your exam, which is always, to me, a very bad way of doing things. But that's what's going to happen.
Yeah, that's what happens when your exams are really spread out.
You're right. You hate that also. And I agree in some sense. You don't get a break. It's very weird. I'm reading this. I'm supposed to understand that tomorrow. Okay. But I was giving you the supposed good news. Energy changes and speed of reaction are not supposed to be very difficult, and it is worth your, for all it's worth, it is worth dividing your time to understand them, even at some risk of your WA1. Okay. Now, however, you're a bit different. Your WA1 do matter for your final grade, something like that?
Yeah, 15%.
15%, right? Now that's depressing. So therefore, now you probably want to, if you're short of time, if you're not short of time, you don't have to hear what I'm saying. But you're short of time, you can probably not focus too much on the energy changes and the speed of reaction because they're easy to catch up.
Okay.
You can probably catch up after the with minimal loss. It's gonna be okay. They are not the hardest chapters. Meaning you can spend more time on practicing WA1, which means I can give you more practice because looks like your teacher will not give you more practices. Right? Do not hope for more practices, but no more. Okay, let me just confirm your teacher will also not give you any, hey, I'm going to have a revision week 1 week before WA1. No, right?
No, that's not a thing.
Why do we do things like this?
My chemistry teacher asked us to trust her because the chemistry teachers in our school apparently have a plan or something.
Have a what?
Have a plan.
Have a plan to?
I don't know, to get us all to pass.
The plan is to get everybody to pass.
That's what they told us at the end of your exam review last year. They said that we should trust them and do their work on time and like.
What do you mean by they? Sorry, this is more than one. What do you mean by they?
All the chemistry teachers were there.
Are in unison saying that?
No, the head of chemistry.
The head of department of chemistry with everybody else there, right? To trust them because they have a plan.
Yeah, because they have a plan or something. And a lot of my seniors last year, when I was like Sec 3 and they were Sec 4, they said chemistry is easier in Sec 4, but I don't know. Never mind. Okay. All right. Okay. Now, of course, I hope that is true. Of course, I hope that is true.
Now, why would your teacher say that, right? Why would you tell them? I'm so sorry. I need to ask this question. I'm so sorry. Yeah. You know most of the chemistry teacher, right? Not just the one that is teaching you, right?
Yeah.
As in, you've heard, you could know how well they teach in your classes, right? Something like
Yes.
then
And we got the worst one.
okay, right? So only for you and Rachel, okay? You got the worst teacher, right? Okay, but that's why you go to tuition, right? That makes a lot of sense. Now, my question is there any in the chemistry department which are actually considered good teachers?
Yes, a lot.
Oh, a lot of good teachers.
Yeah, there are excellent teachers, and they assign none of them to our class.
Okay. Right. Okay.
And I know they're good because I was taught by them in like lower secondary.
Right. Okay. Now the question is, are the notes all the same?
Yes.
Okay. Then how come the note quality is so bad?
I don't know.
Oh my head. And they are good teachers, but they don't assign you more practices.
I'm not sure what the other teachers do. But I know that they want us to buy the chem TYS. They probably do homework from there too.
Yeah, because chem TYS is a standard thing. So your school hasn't bought them for you guys.
No, we're supposed to buy them ourselves.
My head. Okay. More questions. Okay. The more we ask, the more we know, right? But these things are very relevant. Okay, you gotta trust me for we're spending time here, right? But these are just so important. Okay, I understand you get the worst teacher, you get teachers. I still don't understand why come the note quality is very bad and the practices are very bad, but you don't have TYS. Do they tell you this? You should buy 2 types of TYS, one topical, one yearly. Do the topical one first. Yearly is when near the final exam.
Oh, I think we got the topical last year.
As in topical TYS lah.
Yeah, then they want us to buy the yearly.
Yearly, but later lah, right? Okay, not the time. Okay, good. So it's not that bad. Sorry. Where is your topical TYS right now?
It's with me.
Good. Now, do you have the answer key?
I think so. It's inside.
Okay, go check. Go take it.
Okay.
With it.
Oh, Mr. Phillips, I think I brought it back to school and left it in my locker.
Okay. Unless you have time to do it in school, yeah. Unless they ask you to do it in school. Unless you bring it back and we'll practice with it.
Okay.
Okay, because no, never mind. No, never mind. We'll just do that. Okay, there's no point leaving it if they are not asking you to do it. If they ask you to do it, then you don't have to bring it back. Okay. When you look at your topical TYS, this is just something I want you to do until next week. You look at the chapter redox chapter, and you look at the reactivities chapter. You look at those questions and you see whether you recognize them. Whatever questions I give you will be a slightly harder version of that.
Okay.
Okay, seems to be suitable for your school. Okay, I get it. Okay, fine. Okay, now now seems to be a good time to start whatever stays the same, no matter the question. Okay. Okay, so take your paper or take your good notes, right? And then right now you're looking at my video from your laptop.
On my father's iPad.
Good. So you have 2 devices, right?
Yes.
Good for you. Okay. Now, just if they don't give you a way to remember your activities, good. Most of the time, they give you a very slow, not suitable for exam 1. Let me repeat my way. 1, 2, 3, 1, 2, 3, 1, 2, 3. What is this?
Potassium.
Group 1, which has two things, potassium and sodium.
Oh, okay.
Group 2, and then group 2?
Calcium.
And magnesium. Group 3, which... Okay.
Yes.
You are not to write down or remember the English name. It's useless, totally useless. You are to remember the, you know, the chemical name and only the shorthand chemical name. That's all you need. Yeah. What's the 3 in the middle? First, the middle one, the most popular metal.
Iron.
Iron. Good. And then these two are zinc and lead. Okay.
Okay.
Then these 3 below are in some ways the Olympic medals, right?
Oh yeah.
The U, AG, and copper. It's not bronze, but yeah, copper. Okay, can you remember that right now?
CuAg. So copper, silver, gold. Okay.
Okay. Again, one more time. I'm repeating exam. I expect you in exam to immediately do that. Tap, 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 tap.
Okay.
Don't even have to fill it in as long as you're confident you know what's there. Filling it in can sometimes make this less useful. I'll show you later. So just like the organic chemistry, I don't go and fill in all the details here, right? I use, okay, we're going to do this guy, you know, we're going to do that guy. I think you're going to do this guy, understand? Kind of triggers your memory on what's going on. Okay? Or in the aim, right? So this is a very important tool to use in exam, and you're going to use it in this manner. Now I'm going to add my version, which is very useful. Remember, dot, 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 group 1, group 2, group 3, your zinc, Fe, and your Pb, and then your gold medals. You add a mirror image, dot, dot, dot. The mirror image down here are all the ions. So these are the metals. These are the ions, okay? Metal ions lah. So like that, dot, dot, dot. C4 plus if you want, and dot, dot, dot. Okay? The mirror image is what it is called, mirror image, look. Okay? So if this is Fe, this will be Fe2 plus or Fe3 plus. Just pretend that they're in the same place right now. Do you understand what I'm saying?
Yes.
Now, this mirror image serves a very important function. I will immediately use this modified reactivity series to explain displacement reaction. Displacement reaction is the first thing they try to use as an example.
Okay.
Most people end up memorizing it, and they will ask you to give reasons, and again, most people memorize it. It's not helpful at all. Yeah, this is supposed to be a very understanding type of thing, right? Now, you have Fe, and of course, if you want, you have the metal ion. Okay, give me another metal.
Magnesium.
Okay, whatever metal you give me is going to be either on top of Fe or on the bottom of Fe. I guess that makes sense. Where's magnesium?
Below. In like
group
the reverse one.
Yeah, group 2, right? Group 2, which is that, right? So I only make visible the metals in question, which is why it's much easier for you to memorize the position. Trust me, this is more like an exam skill. It's very important. Okay. Yeah. Having a full one in your mind and having a partial one in front of you is very good. See you later. Now, Mg, therefore, Mg2 plus is here if you ever need it. Okay. Yeah. Okay. Now, displacement reaction. Okay. The complete way to understand is if you have Mg and you have Fe. Is there any doubt in your mind that if I write Mg, that is an Mg metal?
No.
Good. Fe, Fe metal, right? I also have Mg2 plus, which is not a metal. It's a metal ion. Fe, I'll just choose 3 plus for convenience. Okay. Now, displacement reaction asks you something like this. If I put two things together, will something happen? In the simplest way possible, that is what displacement reaction means. Okay, so if I put these two things together, will something happen? If I put these two things together, these two things together, and these two things together. Finally, there's the last combo, these two things and these two things. This is the only combo you can make. There are 6 combos. Am I correct?
Yes.
Okay, good. Now let's go through one by one. If I put Mg and Fe metal together, will anything happen?
Wait, Mg and Fe both metal?
Both metal. Yeah.
Yes.
Something will happen. Please tell us what.
Combustion?
No. Combustion is a word reserved for burning with oxygen.
Okay.
Right now, since there's only 2 metal, we pretend there is no oxygen, blah, blah, blah. Will anything happen?
Oh, it's an alloy.
Oh, well, yeah, you can see that. Okay, you can mix them together and become an alloy. Now, an alloy, we pretend, yeah, in secondary 4, we pretend that that's not a reaction at all. Or rather, there is no reaction happens, or rather like that. Okay, we pretend. So, we call that no reaction happen. I suppose it's not the same as nothing happen. You can mix them and they become stronger. That's fine. Good for you. Okay, but that is not what the reactivities chapter is all about. So, good for you. Now, the next combo. Sorry.
You'll get a reaction.
You get a reaction. What would that be?
Metallic bonding.
Okay. Now that is totally wrong, and I have to explain why. That means your secondary can be made more solid. Now, metal bonding is exactly what happened between metals. I suppose that's metal bonding between metals. Now, in alloy, which are mix of metals, there's still metal bonding. You're applying metal bonding to ions, totally off.
Oh.
Make sense? Even though in the drawing of the metal bonding, you actually draw ions. It's very confusing. If we check out your metal bonding drawing, you will be drawing Mg2+. Very weird. Another Mg2+. And then whatever, the same thing, 2+, 2+, or Mg2+, a lot of them. And then you'll be drawing your C of this dislocated. Delocalized electron. So that is a metal bond. Now, the ions there, the Mg2+, is not the Mg2+ here. This Mg2+ here is free from any electron. This Mg2+ still has his electrons circling around here, therefore making him a Mg. This is an illustration of I don't get to be an ion. Not that I get to be an ion. I don't get to be. You must understand that metallic bonding is a metal being very sad. I want to be an ion, but in reality, I am not an ion. I am still surrounded by my electron and everybody else's electron. So yes, you have to draw the Mg2+, but that is not an ionic one, nor is it a true ion. Do you understand what I'm saying?
Yes.
Does my drawing make any sense anyway?
Yeah.
Okay. Please don't misunderstand that drawing, though. Now, to say that an Mg2+ with an Fe3+ meeting and therefore have a metallic bonding, definitely not the case.
Okay.
Would that be okay? Okay, now. Mg2+ and Fe3+, no reaction. I'll give you the reason why. Because they are both pluses, they cannot even approach each other. They repel.
Right.
If they cannot even approach each other, so to speak, they repel because they repel each other, how can there be a reaction?
Oh, okay.
It's a very physical explanation, and it is an explanation of every reaction. It is a very physical, can I reach you or not? Close. And yeah, so no reaction. Never is there a reaction between a positive and another positive. Never. Okay, same goes with negatives and negatives. Now let's try the other combo. Mg metal meeting Mg2 plus. Will anything happen?
No.
Yep. No. One is happy, one is sad, right?
Yeah.
That's it. Look.
Okay.
Fe meeting Fe3 plus.
No.
Okay. Now, knowing that there's no reaction is equally important in chemistry. They also never specifically say this. It's weird in my head. It's very weird. Just because it's not tested in exam doesn't mean that it doesn't complete your understanding. So good for you. Now there are two more combos. What are they? Okay, come on. There are two more combos. What are they? Wait, Farah, you have no idea, is it?
Wait, what? I'm not seeing anything.
Oh, no, it's still here. There are two more combos. So I'm asking you actually. There are two more combos. What are they?
Oh yeah, Mg and Fe3 plus.
Okay, this one. Same question. Reaction.
Yes.
And what exactly is the reaction?
Displacement.
Right. And you will be correct. This is displacement. Now, to test you, the last combo, any reaction or not?
Yes.
The answer is, I'll put a question mark. Okay. Now, as if there is a reaction and it's a paper 2, they will ask you to explain. Okay, I'll give you the formal phrasing later. I will give you the understanding first. That be okay?
Okay.
Now, remember, in the reactivity series, the guy above, all metals, right, is what we like, but they don't like. Okay, we call them unstable. See, they're very unhappy.
Yeah.
And there's an order not because there's a theory about it. This is purely by experiment. They experimented and they found out that certain metals are more reactive than other metals, and they can make an order. The order is very stable. Clear? It's just by experiment. You don't have time and money to experiment all of them. So they replace experiment, very good, by memorizing. Can ya? So if you're bringing this memorizing, you're bringing the experiments that are going to be valid. So the experiment says the guys on top are very, very unhappy. The guys here, for example, there is an AU here. There is an AU here. They are quite content. But if AU can become ion, they will, if they want, if they can, they will. So slightly happier. And here, very, very happy. Would that be okay? That makes some sense. Remember, the mirror image is not there in your notes usually, but it's going to be very helpful. Helpful how? I'm going to show you right now. I'm going to erase this. I'm going to erase that. Okay, I'm going to erase this. I'm going to erase that. And right now, I am going to erase the green one, right? The green one is Mg and Fe3 plus. Green and green. And you say there's a reaction. The reaction looks like that. Let me be clear, there is no other way, no other reaction possible. If there is a reaction, the Mg will become Mg2 plus, end of story. It will not become Mg2 minus, it will not become Mg3 plus. There's only one way for Mg to become something else, Mg2 plus.
Okay.
In some ways, the life of Mg is very simple. Oh, Mg reacts, Mg2 plus must be like that one, whether with oxygen or whoever, we don't. Now, Fe3 plus, when reacts, we simplify his life, will become Fe. That's all there. Can ya? Make sure? Understand?
Yeah.
Now look at this reactivity series. Going down implies something easy and automatic. Dropping down, okay?
Yeah.
Jumping up represents something that requires effort or energy. Do you see that the Mg going to Mg2 plus is a jump down, which is bigger
Yes.
than the jump up? Now, this is a very easy indicator that the displacement reaction will happen.
Oh.
This will happen. Let's compare it with the other scenario. In the other scenario, I'm going to put the green one here. Okay, come on, it's easier to see that. Yeah, that's the green one. And the other reaction is pink, right? You think that, hey, nothing wrong. I just swap the Mg with Mg2 plus, blah, blah, blah. But look, if the reaction happens, there is no other way but Mg2 plus to become Mg. And if Fe is to be displaced, Fe will become Fe3 plus. Make sense?
Oh.
But in this pink one, the jump up is bigger than the jump down. So it does not happen simple. Very simple. This is a very reliable understanding. Go ahead.
Yeah, this makes sense.
Okay. Any combo can be, will it work or not? Oh, jump up bigger than jump down. Not going to happen. Simple.
Okay.
Jump down bigger than jump. Okay, it's going to happen. No matter how you say it out, that is true. So this is no displacement. As for the word displacement, remember that metal wants to be metal ion, right? So, Mg is displacing Fe3 plus. You don't say it the other way. Do you understand that? You also shouldn't say Fe3 plus displaces Mg. They will see it, okay, wrong sentence. You must say Mg displaces Me3 plus, meaning Mg takes Fe3 plus place as an ion. Mg wins, whatever. Mg becomes ion. His life goal has been achieved.
Oh.
Fe3 plus, which returns back to Fe, meaning he had taken one step backward. As a metal ion, his whole life saving is lost. He becomes Fe again, whatever. That's what it means. You cannot say it the other way. You must say it from the metal's point of view. You learn from secondary 3, metals want to be metal ion, metal want to be metal ion. So you say it there. Okay. Fe cannot displace Mg2 plus. That's how I word it. Okay. Okay, and then they will ask you to explain also, how come how come there's no reaction? They will say that, okay, oh, Fe cannot displace Mg2 plus because blah, 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 jumping up, jumping down doesn't work.
Yeah, what are the formal terms?
Okay, so the proper phrasing now. Now the explanation is clear, yeah? Now the phrasing, okay? The phrasing totally does not make sense to me lah.
Oh.
Why? Because they eliminate the other half. You are planning to take chemistry in year 5, year 6, right?
I don't think I have a choice.
All right. The moment you enter year 5 or year 6, whenever they decide to reintroduce it, yeah, they immediately show you the mirror image. Ta-da! Don't ask me why in Sec 4 they never introduce it.
Oh.
It introduced too many problems to me lah by not introducing it. So easy to understand. Never mind. So again, my point is this way of thinking is very valid, but their phrasing does not make sense because they are limiting themselves. That's really my point of view in this case. I really don't. So now if I erase this, if I pretend that this doesn't exist, please understand, yeah, Vera. Oops, it really disappeared. Sorry. Thank you, scribble function, right? Please understand, Vera. The thing actually exists.
Yeah.
Fe do become Fe3 plus or Mg do become Mg2 plus. Yeah, so the thing exists. But if you pretend that it doesn't exist, then your explanation cannot be jumping up, jumping down. Cannot be. Okay, clear? Eh? Your explanation must only rely on half of the reality. And therefore, it goes like this. Why do Mg displaces Fe3+, right?
Mhm.
Look at the reactivity series, which is only half according to them. Believe it or not, you cannot even mention Fe3+ in the explanation. It's so weird. Because to them, the Fe3+ doesn't exist in the reactivity series, but there is no other way to explain it. So the explanation goes like this. Because Mg, answer, more reactive than Fe. Finish. Which is if you want to make it more clear, because Mg is above Fe. Above means more reactive. Of course, you shouldn't say above, but you should say more reactive.
Okay.
One more time. The question is, how come Mg displaces Fe3+? The answer is there is no Fe3+. Mg is more reactive than Fe. Congratulations, you got the marks.
Okay. Is there anything relating to like ions? Would they ask you to explain about that?
You mean in a kind of this reactivity series question or this displacement reaction question?
Yeah, because one of the notes, the activity guiding question is, what is the relationship between the reactivity of a metal and its tendency to form positive ions? So my guess is that some of the answers are going to ask for ions.
Look at this. No. Again, the reactivity. Okay, I'm going to answer with half the reactivity. And then I'm going to answer it with full. Okay? Full is my version. So if I have half, I cannot say jump down. Right? Let's say the relationship goes like this. The more reactive the metal is, or the higher the metal is, right? Higher the metal is, the higher its tendency to form its ion. Sounds very fancy, but I don't think it makes a lot of sense. Okay? You get my answer? Okay.
Yes.
Now, I'm going to answer with the full one. Okay. Answer with the full one, I'll just say jump up, jump down. Okay. Now, hey, the full reactivity series. Hey, the higher the metal, the deeper or the lower it jumps down, right? The higher it jumps down. Correct or not? The lower the metal, the jump down is so small. The higher it is, the lower its jump.
Yes.
Correct, right? Because it's a mirror image. Now, jumping down is a representation of its releasing its energy. So Mg jumps down very low to become Mg2+. Let's compare it with Fe. Fe also jumped down to become Fe3+, but not as much. So therefore, given a choice, Mg will like to jump down more than Fe.
Okay.
Right? That might be using nonsensical words, but it makes a lot of sense. Now, you don't have that full one, so you have to use the fancier words and the reactivity series and whatever. Now, am I answering your question?
Yes.
Right. Since you already have the questions, you want to ask anything first? Because I am just starting with reactive series. This is not the only function of reactivity series.
Do you think explain the positive and negative ions?
Okay, I'll give you something better. Now, I am guessing your teacher hasn't shown you the negative ion reactivity, right?
I don't think so.
Yeah. So when they say reactivity series, they traditionally only refer to the metal ions, which is fair, right? So again, C, H, dot, 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 and it's mirror image, right? Now you see why I like dots a lot. I don't like to rewrite things, right? But you get the point. Now, if there is a metal to metal ion, then of course there's also non-metal to non-metal ion. Of course. F, Cl, Br, I. This order you should almost already memorized it. Do you know what order this is?
This is the, what's that?
Pyrene group 7 hydrogen.
Yes.
Okay. You don't have to memorize it, but it's very nice to. Okay, FClBr. Putting oxygen here for whatever reason. Oxygen is not group 7, but I'm putting it in. Okay?
Okay, wait, double confirm. These are all diatomic atoms, right?
Most non-metals are diatomics, but the more you go down, like iodine, yeah, you can say iodines are diatomic. Yeah, I guess so. Sure. Okay. Now, this is all the non-metals that we're going to worry about. We're not going to worry about other non-metals. And then I have the, the mirror image also, right? And the mirror image is exactly like what I said. Right? Make sense? It's a mirror image. Yeah. Now, without much explanation, I'm gonna make this into OH minus, right? Without much explanation, right? Now, I'm gonna show you the positive and negative ion thingy lah, right? Okay. So remember, metals want to be metal ions, and non-metals want to be non-metal ions. This is in general true, right? So this is saying metals are unhappy, non-metals are unhappy. We like them, they don't like themselves. In order to do that, they have to work together. Now, this is what we teach you in redox, whether we realize that or not. I am now covering redox right now, okay, by using the positive and the negative reactivity series. I am covering redox to make it more sensible. Ready? Okay. Now, do you understand the metal to metal ion is obviously always an oxidation? And in this case, this is always a reduction.
Okay, yes.
Okay. I'll put this as a diatomic version, so that's easier.
Wait, why?
Because metal do exist as, I guess, sodium, we can write down as sodium, but practically speaking, there is never an F. There is only F2. There's only O2. There's only Cl2 and F2. As in, you learn in Sec 3, non-metal almost always exists as covalent bonds. Diatomics are covalent, right? So this is a more accurate way of writing it. Okay?
Okay.
Okay, now, the covalents are reduced to become ions. That is their life goal. Simple. Okay? That's their life goals. We call Cl2 very reactive because they don't like to stay themselves. They want to become Cl minus. Therefore, please understand Cl minus is very stable, even though hydrochloric acid doesn't sound stable at all. Cl minus is very stable. Yeah, so far so good?
Yes.
Now, the part of them working together. Now, you must understand why the term redox is always used. It's reduction together with oxidation, or in this case, I'll cancel it as ox-rep, because oxidation is on the left, right? Because there is never an oxidation without reduction. If you understand that, you are probably halfway through redox already. Do you understand that?
Yes.
Tell me why then, using your own words.
Because in an equation, when an oxidation happens, like maybe from the left to the right side, there'll also be a reduction happening from the right to the left.
Yeah, but why? I mean, the universe doesn't allow only oxidation or only reduction. Why?
Because the electrons have to go somewhere.
Very good. Electrons cannot disappear, and electrons cannot just fly into the air. Do you know why?
No.
Because when the electron tries to be ejected, it's more like the electrons do not want to leave it, okay? But the metal wants the electron to leave. Go away, shoot, shoot, shoot. But the metal The metal has a positive core mass, so when they try to eject the electron will come back. It's that simple. They have to try to eject the electron immediately to somebody wanting to take them. The electron is never really free. The electron is immediately transferred from somebody to somebody else. It cannot be ejected because it'll just be attracted back. If that makes some sense.
Okay. Yes.
Okay. So I am trying to oxidize myself, say metal with a light bulb. So light bulb of oxidizing himself. I need the help of a non-metal. Because the life goal of a non-metal is to acquire other people's electrons. So that they become a negative ion. And this story is the story that you hear in secondary 3. So far, so good?
Yes.
Okay, and that is the story of redox, except that now they tell you, hey, people, if this arrow is oxidation, then the arrow up is reduction. And if this arrow is reduction, the arrow up is oxidation. Make sense? They're just each other, correct? Would that be okay?
Yeah.
And now, therefore, if I have a Fe here, which I try to go down, I try to oxidize, I can ask the help of a Br2, correct? I can. Make sense? Let's go down together. Let's go down together, and I think Br2 will agree. Meaning, when Fe metal meets Br2 gas, they will react because they are happily helping each other.
Okay.
But Fe can also ask the help of his trusted buddy Ag2+. He can also do that. And that is also an oxidation reduction reaction. This is the displacement we just talked about. Do you understand? He is giving his electron into Ag2+. And that can be done.
Okay.
But he cannot ask his help by another friend, Mg2+. He cannot. Why?
Because Mg is more reactive
than Fe. And that is your formal phrasing of things.
Okay.
Our understanding is the jump down is smaller than the jump up. That's it lah. So far, so good?
Yep.
This is the two major things. Did I answer your question just now?
Yes.
Now, I want to address one rust prevention before we end. Also using the reactive series. Actually, Actually, I want to address so many things. Now, I'm going to now pretend that the negative reactive series doesn't exist first. You will definitely need him in electrolysis, which is the troublesome chapter after energetics and speed of reaction. Okay, there we start. Now, there will be some time before that. Now, I want to explain something here. First, I promise you that the memorization will be easier. You don't have problem with memorizing, isn't it?
Recently, yes, but
what do you mean?
Because memorizing takes a lot of time.
Yes, and I'm just trying to reduce the time. Okay. Now look at that table. I was telling you, you don't have to tell me, just look at it. Okay. Now, Rachel, you do the same, yeah? You take your notes also. So reaction, first of all, with cold water, right? Now, does it make sense? The more reactive the metal, the more likely to react. Correct or not?
Yes.
There is a limit lah. There's a limit. And the limit is here, look. There. Of which above will react, below will stop. No reaction. Correct?
Yeah.
If you just memorize this as the limit, meaning Mg will react with cold water, normal water. Cold water means normal water. The rest don't. Then the wording itself becomes simple. Mg will slowly react with cold water, right? Slowly. There'll be little bubble as a result. Calcium will react more vigorously, I suppose.
Yes.
Sodium will react, well, vigorously, because you are trying to apply more
violently.
Violently, and potassium therefore explosively, or whatever that is.
Yes.
Okay? I suppose you have to memorize the adjective a little bit, but adjective itself makes sense because it's a gradual increase. Just like the reactive series orders. The reactive series can predict all those things. Do you understand? To me, I just memorize the limit first, and the adjective will apply itself.
Okay.
Now, hot water or steam, whatever it is.
Steam. Wait, hot water is basically steam, right?
Oh, you're not a physics student. Sorry. Hot water 100 degree and steam 100 degree. I guess chemistry still talk about this. Which one is, so to speak, more dangerous?
Steam.
Because it contains more energy. Right? The physics student will counter, but it's also less dense. Okay, but you're right. Steam contains more energy, but remember, it's less dense. So steam is useful for you to just make sure that if there's a reaction, it will happen. Let's just say that you're going very, very high energy here. And what is the limit? The limit is around here, I believe. Correct? Yeah, the limit is here. Correct? Fe will react, and then the adjective starts again, slowly, and then faster, violently, explosively, and whatever. Correct? I think they put an upper limit in Mg here. Correct?
Yes.
Do you know why? Does that mean that Ca will not react with steam?
No, it says Ca, Na, and K will all react explosively.
Yeah, which is a very nice way of saying don't try that even at a safe lab because it will kill somebody.
Oh.
Right? There are reactions that are not to be attempted even in the lab. Okay, understand, yeah? So the word for that is it's too dangerous. So they put a maximum limit not because of reaction limit, but because of safety limit.
Yeah.
Okay, good. Again, I will just memorize the lower limit. The upper limit is for safety. Usually people don't test it. Okay, now dilute acid. Very conveniently, there is the same limit. Correct or not? And I believe the maximum is also the same. Correct?
No. The
maximum is?
Ca is the maximum.
Oh, wow. They're very daring. Okay. Maximum Ca is that. Now, pray tell, how come they never put concentrated acid?
Because concentrated acids
will
explode?
Yeah, will be very dangerous. Let's be clear. Concentrated acid is available in the lab. Yeah. Correct? What is the first thing you do when they ask you to take an acid?
Check whether it's aqueous or concentrated?
No. Well, I suppose there's a dilute one, but if they ask you for a concentrated one, they immediately ask you to dilute it because they will never perform an experiment with a concentrated acid. Okay. Right. So that's why there is no table for concentration, not because it doesn't work, but because maybe all of them will react fast. Okay. Then there's safety limit built in these things. I'm telling you this to introduce certain logic to it, to introduce certain consideration, makes it less cold, less dead. Okay? Yes. Now, if this helps you memorize, good for you. Is it helpful? Now, last one. The metal carbonate is the most confusing one. Yeah. It is because they insist to not give you the full one. Now I give you the full one. Okay, now again, this is the reason why you don't write down fully, because it takes time. Now, let's say you start with, the interest here is basically sodium carbonate and calcium carbonate. Those two are the limit. There's a limit to the carbonate decomposition. Correct? And the limit is calcium carbonate. Am I correct?
Yes.
Instead of starting,
No.
calcium carbonate can be decomposed and sodium carbonate cannot.
Yeah.
Correct? Now, your teacher will draw the limit on top because of the limitations. But in reality, metal carbonates are not, metal with cold water, not metal with steam, is not metal with dilute acid. What is the chemical name of calcium carbonate? You don't know?
CaCO2.
Very good. CaCO3.
Oh.
Now, my question to you is, CaCO3 is Ca plus or Ca?
Is C plus.
Good. So CaCO3 is actually here, not up there, which is a totally different thing from all those trees. That's why people never understand carbonates. And sodium carbonate is also here, right? Which is to say it's also an Na plus, not an Na metal. We are not sodium metal. We are not dealing with sodium metal. We're dealing already with calcium ion and sodium ion.
So basically carbonates are like opposite?
It's over here. What else can I say? It's down there, so to speak.
Yeah.
Down there. Now, however, we're talking about things down there, the explanation must be up there. Don't ask me why. That's the part that never makes sense. There is a problem. You shouldn't have that problem. Rachel shouldn't also. Everybody else shouldn't also. It's an unnecessary problem. So far, so good? Now, to decompose is very simple. Decompose is to break down without anybody's help, except for heat. So in a decomposition reaction, you don't see plus anybody. That's the rule. But heat, if you like. Heat is not considered, anybody. Okay, for heat. Now, it will decompose, in this case, to Ca plus CO2. That part is the easy one to memorize. Okay, now, my logic is very simple. I'm presenting a very simplified logic to you. Decomposing is almost like jumping up. You're asking calcium carbonate to jump up somehow. It will not quite reach calcium metal, but you will notice, for example, if they give you copper carbonate, which is quite hard here, okay? Copper carbonate, if your note is complete, will tell you that copper carbonate immediately becomes Cu metal, just like that. No explanation given. Some carbonates can just become their metal counterparts by heating them, but some do not quite reach their level. It is still similar to the effort of jumping up. Why? You are heating it, man. Heating it means giving it energy. Jumping up requires energy. I hope that makes some sense.
Yes.
Now, why is the limit therefore in calcium carbonate? Don't know, it's experiment, but I hope you understand sodium carbonate have too great a difficulty of jumping up. Calcium carbonate is the lowest you can expect it to jump up. Okay. Sodium carbonate will never make the jump. Will never decompose. You're saying?
Okay. Got it.
Sorry, you're saying?
Huh? Oh, no, I just said yes.
Okay. Okay. And the lower the carbonates are, I don't use higher, right? Your teacher will use, higher, I will use lower. The lower the carbonates, the higher the heat required. That makes a lot of sense. You're forcing a jump up, which is, much bigger, so to speak. So I hope that makes sense. The rest of the details should be memorization. Now, is it helpful?
Okay, got it.
I hope this clears a lot of stuff. This is what you need to answer the question, which means I'm already giving you, hey, the type of question you see will be like this one. It's not going to be very far. Okay. The only thing we didn't cover is rust prevention. It's a problem because your note don't contain anything. I have to explain a bit more. So next time now.
Alright.
Now,
Then the metal oxides, I have to memorize that too, right?
What do you mean? Sorry. Oh, metal oxide. What's the reaction? Oh, metal oxide with steam, for example.
Oh, with carbon and hydrogen.
It's not a very difficult thing. It follows the same logic. Did that make sense? Oh, I know where the metal oxide carbon comes from. It's from blast furnace lah. Hi. Yes, you do have to memorize that, and yes, they will ask that. And if you have difficulty, I'll explain a bit more.
Okay.
Okay. Now, just be assured that they will use the opportunity to test you on all that. These are memorization that they consider important. I'm offering you the explanation, I suppose.
Okay.
It's not possible to give you homework, right?
Preferably not.
Okay. So the two things I need you to do is to make sure you got this memorized next week. I'm serious.
Okay. Yeah.
Getting it memorized is very good for doing the questions. It's very good and it's very easy now. I hope. Secondly, prepare your TYS. That's all.
Okay, I'll bring TYS home next week.
Good. Anything else, good?
Nope.
Next week is Sunday. Is also number 3 is still the second day of Chinese New Year. Please ask whether it's possible or not. I don't think we can miss the lesson, right? But please ask your parents first.
Yeah.
Okay?
Would be okay.
Let's communicate and I will see you next week.
All right.
All right. Bye-bye.
See you. Thank you.